Today we're going to start working on factoring polynomials, which is going to build on a lot of the skills that you used last unit with factoring quadratics. So the problems at the bottom of your warm-up are the same as the ones that were on your homework. So hopefully you can figure out how to do those. You have a GCF, difference of squares, and then just an X factor. And then the bottom is an AC split. Well, you go ahead and do those. We're going to actually use those same methods, though, today when we're looking at polynomials. So the only difference you're going to notice in what we're doing today and what we did last unit is that my exponents are a little different. So we had an x squared here, an x there before. Now we have x to the fourth and x squared. When we have x to the fourth and x squared, we can still factor using the same methods. We just need to pay attention to our exponents. So we're going to go ahead and do this. So just like we did in last unit, we have three terms. There's not a leading coefficient, so there's nothing out front here. So I'm just going to go ahead and do x factor. So negative 28 is on top and 12 is on bottom. So the two numbers that multiply to give me negative 28 and add up to 12 are 14 and negative 2. So since this is an x factor, I can go right to my parentheses. And typically that looked like this. Okay. The big difference, though, is those exponents. If I take x to the fourth and split it in half, that means I have x squared there and x squared there. If you don't have your x squareds, it's really going to mess up your answers. So that is the only change. Once I get here, I need to solve. So set each part equal to 0, and then solve it. I can't factor that any further, so I'm just going to go ahead and use the square root to solve this one. So remember the square root of negative 14, because it's a negative, I have an I. 14 I can't break down at all, so I'm going to leave that in there. So plus or minus I squared root of 14. For the second one, I'm going to go ahead and add 2 to both sides, and then again take the square root. And I cannot break down the square root of 2 at all, so I'm going to leave it as the square root of 2. Don't forget your plus or minus sign for that one. The reason the second one doesn't have an I is just because it wasn't negative. Let's do a second one. Okay, 18 on top, negative 11 on bottom, so I have negative 9 and negative 2. So if I'm going to go ahead and factor this, remember because this is x to the fourth, when I split it I have x squared minus 9 and x squared minus 2. And I can do one of two things. I can factor this first group further, or I can go ahead and set each part equal to 0 and solve. So if I factor this further, I'm going to use difference of squares. So the square root of 9 is 3 and negative 3. But if you don't recognize that, that's fine. We can go ahead and solve from there. So I'm going to go ahead and do x squared minus 9 equals 0. And x squared minus 2 equals 0. If you went ahead and factored further, you can go ahead and set all three of those equal to 0 and solve. So I'm going to go ahead and add 9 to both sides. And take the square root of 9. So remember we have a plus or minus sign when we do that. And then I'm going to add 2 to both sides. And then take the square root of 2. And I can't break that down at all, so I'm going to leave that inside my square root. Again, don't forget your plus or minus sign. So notice for both of these problems, because of my plus or minus signs, I actually have positive and a negative answer there, so that's 2 answers. And a positive and negative answer there, that's 2 more answers. If I have x to the fourth power, I should have 4 total solutions. And so notice for both of those, with those plus and minus signs, I do have 4 solutions. Okay, last one here, no GCF, 3 terms. I'm going to do my x again, but because there's that number out front, that leading coefficient, I need to use AC split. So 5 times negative 8 is negative 40. 39 on bottom, so I have 40 and negative 1. So I'm going to do 5x to the fourth. Now, here's the difference. Instead of having 40 x's and negative 1x, because this is an x squared here, we have to have our squares. I'm going to go ahead and make 2 groups and factor out my GCF from each group. So I'm going to take a 5x squared here, so I have x squared minus or plus 8, and negative 1 there, so I have x squared plus 8. If these two don't match, we're in trouble. Go back and check your work. But they do, so I'm going to pull x squared plus 8 out front, and then 5x squared minus 1 makes my next group. We're going to set each part equal to 0 and solve. So I have x squared plus 8 equals 0, and 5x squared minus 1 equals 0. So if I subtract 8 from both sides, and then take the square root, this one I can break down. So the largest perfect square that goes into negative 8 is negative 4. So the square root of negative 4 is 2i, and then that 2 is going to stay on the inside. For this next one, I'm going to end up with a fraction. And if you remember when I told you back in the last unit that simplifying radicals is kind of becoming something that you don't really need to worry about so much because you have a calculator in your hand, we can do something called rationalize. Okay, right now I have the square root of 1/5 as an answer with my plus or minus sign there. You can absolutely leave this. Those of you who think you might go on to accelerated, actually if you're going to go on a pre-calc or accelerated pre-calc, you will learn to rationalize next year. What that means is I'm not allowed to have a square root around the bottom, so I'm going to multiply both the top and the bottom of the fraction by the square root of 5. So I get the square root of 5 over the square root of 25, and I'm going to simplify the square root of 25 on the bottom. So I get this. That's the same thing as this, and this is mathematically correct. However, I will take this. Okay, I don't want you to do those extra steps unless you're really on top of it. Okay, so there's my 4 solutions there. Next two, it says factor and solve. Let's add some equal zeros here. Okay, remember that x to the 4th is a perfect square. We can break it down to x squared times x squared. So we're going to use the difference squares here. Notice I can take the square root of 9x to the 4th and get 3x squared. So I'm going to go ahead and do that. And the square root of 25 is 5. And then 1's plus and 1's minus. And this only works if there's a minus sign in the middle. And then we can go ahead and solve. So 3x squared plus 5 equals 0. 3x squared minus 5 equals 0. And then go ahead and go from there. Okay, when I simplify this one at the end, all I need you to do is put an I out front. You can leave the fraction like it is. Same thing for the second one. Go ahead and solve. And when you take the square root for this one, just don't forget your plus or minus sign. Don't need an I there. Don't need to break down your square root at all. Okay, so those are your 2 answers. 4 answers there. Do the next one. Again, square roots. I can take the square root of 16 to get 4. So 4x squared. Square root of 81 is 9. So that's what I want right there. And then 1's plus and 1's minus. We're going to set each of those equal to 0. This one's a little different here when we simplify, and I'll show you why in a second. You can actually break this down a little more if you want to. You can keep factoring it. You don't have to, because we can solve from here. So if I take the square root of both sides, the square root of negative 4 is 2i, and the square root of 9 is 3. So actually I can get rid of my square roots in that one. Break it down. So if you can simplify, go ahead and do that. Okay, solving the second one, notice, hang on, I flipped my fraction in the first one. Sorry about that, my negative 9 should have been on top. So negative 9 over 4 gives me 3i over 2. And then positive 9 over 4 gives me 3 over 2. So 2 solutions there, and you are good. So that's your second method. Technically your third. Last one is factor by grouping. There's 4 terms here. This is very common in this one. Watch your signs, so that's a negative 2 there. Take out your GCF, which is x squared in the first group, and a negative 2 in the second group. So you get x minus 4 and x squared minus 2. And I'm going to set each part equal to 0 and solve. So for the first one, I just have to add 4 to both sides. There's no x squared there, so I don't have to take the square root. Most common mistake is that students just get in the habit of doing that. Add 2 to both sides for the second one, and then take the square root. Can't break that down at all, so I have plus or minus 2 for the second one. Notice, this time, my biggest exponent here was 3. And I have 1, 2, 3 answers for square root of 2 and negative square root of 2. So it's a good way to check what you're doing there. One thing, so let me pay attention to, is the only time you use factor by grouping is if you have 4 terms. Okay, practice there. Go ahead and pause the video, try these, check them when you are done, and then you can work on your homework. Okay, first one, factor by grouping. I'm going to do this quickly without a ton of explanation. Change my sign there. There's actually a GCF here that I should have done first, so I'm going to take an X out of that second group. So I'm going to set each part equal to 0. So I get x equals 0, x equals 4, and then x equals 1. So 0, 4, and positive and negative 1. Let's do GCF first, it makes it easier. Okay, so because there are only 3 terms, I went ahead and did my x factor, 36 on top, negative 13 on bottom, after I take my GCF out. Since there's nothing in front of my x to the 4th, I can go right to my parentheses. Okay, for this one, you could continue factoring, or you can solve it. Let me go ahead and solve. So for the first one, I get positive negative 3. And for the second one, I get positive negative 2. And I don't need to worry about that because it's a constant, so it's not going to do anything. Okay, let's do our GCF for the next one. It should be an equal 0 there. Actually, we're not going to do a GCF here. It should be an equal 0. There are 4 terms. Make 2 groups. Take out the 2k to the 3rd. And the 3. I wrote this backwards compared to what I normally do. Just go with it. Same thing. We haven't talked much about solving cubes yet, so we're going to talk about that here in a second. I get k equals positive and negative 3 for the first part, or the second part. When I take the cubed root, my answer is either positive or negative, so I don't need to have the plus or minus sign there. So if I have k to the 3rd equals negative 3 halves, I'm going to take the cubed root, and we're just going to leave that. Don't do anything with it. That's not typical. You won't see that on test or quizzes. Last one, x factor, 21 and 10. So I have 3 and 7. So I have x squared plus 3 equals 0, and x squared plus 7 equals 0, and then solve. And same thing here, subtract 7, and square root, and then I need an I, but I can't break those down at all. Okay, If you have any questions,